Hello everyone and welcome back. Today's discussion will be continuing on with plate tectonics, but redirecting our focus from earthquakes to volcanoes. You might be familiar with volcanoes, but in today's discussion, we will describe parts of a volcano, magma composition, and the types of eruptions. A volcano is a rupture in a planet's crust where magma comes to the surface. When magma flows on the Earth's surface, this is referred to as lava. It is important to understand the general scheme of a volcano before we continue on in our discussion. In the following diagram, we have some of the main features of a volcano. This includes the ash plume, lapilli, which is a size classification of fragmented material from a volcanic eruption, and lava flow. In addition, there are layers of lava and ash, stratum, which is a layer of sedimentary rock, and a dike, which occurs when magma rises into a fracture or creates a new crack by forcing magma through the rock. The magma chamber is a large pool of magma under the earth, and the magma conduit, which is the pipe that carries magma from the chamber to the earth's surface. Volcanoes can be located on land, known as subaerial eruptions, and under a body of water, such as an ocean or a lake, and are referred to as subaqueous eruptions. Volcanic eruptions can be catastrophic and can completely devastate the surrounding areas. Some well-known volcanic eruptions are Mount St. Helens, Mount Vesuvius, and Mount Ruiz, to name just a few. To understand what causes these catastrophic events, we need to begin with discussing magma generation and composition. Volcanic eruptions vary drastically to one another, and each eruption is unique and can vary in size, type, and composition of eruptive material. Magma and lava have three components to it: melt, solids, and dissolved gases, known as volatiles. Melt is the liquid component and contains ions from melted minerals. Solids are any minerals that have not melted because the melting temperature is higher, and volatiles are the dissolved gases in magma and can include water vapor, carbon dioxide, sulfur, chlorine, and many others. Depending on the dissolved gases, these will affect the behavior of the magma. Mafic tends to have 1 to 3% dissolved gases, intermediate magmas are about 3 to 4%, and felsic magma have between 4 to 7% dissolved gases. The composition of the magma will determine the eruption style, type of volcanic cone that is formed, and the type of rock found at the volcano. A majority of magma originates in the upper mantle, which accounts for the plastic behavior of the asthenosphere, and typically generated in one of the following scenarios. 1. At divergent plate boundaries, for example, oceanic ridges. 2. Over subduction zones. And 3. Located at hotspots, which are areas that are not associated with plate boundaries but has volcanic activity. In order for magma to be generated, it needs to be at a high enough temperature and low enough pressure for rocks to melt. Depending on the location and the minerals around the magma will dictate the composition of it, in proportions of silica, iron, and magnesium varying the most. Mafic magma has a lower content of silica and higher content of iron, magnesium, and mafic minerals including olivine and pyroxene, whereas felsic magma has a higher silica content containing lighter colored minerals such as quartz and feldspar. A major difference between felsic and mafic magma is the viscosity of it, which is a liquid's resistance to flow and is typically described as the thickness of a liquid. For example, syrup has a higher viscosity than water. Felsic magma has a higher viscosity than mafic and does not flow as easily on the surface. As a result, felsic magma tends to stay within the magma reservoir and forms igneous intrusive rocks such as granite. If felsic magma rises into a magma chamber, it can get stuck due to its high viscosity. This can result in the trapping of dissolved gases, leading to a buildup of pressure which can lead to an eruption. The viscosity is important because if gases are able to escape from magma, this will flow more gently, whereas if gases cannot escape and pressure begins to build, this can result in a violent eruption. As you can already see, the type of magma located in the magma chamber will determine the severity of eruption. An explosive eruption can be catastrophic and cause more devastation and a result of felsic magma. This occurs because the dissolved gases are unable to escape and build up pressure, and the gas-rich magma churns within the chamber. Eventually, the pressure buildup becomes too much and escapes and explodes. As a result, magma, rock, and ash burst forth in an eruption, and this material is known as tephra. Hot tephra, ash, and gas can speed down the side of volcanoes as a pyroclastic flow and reach speeds as high as 700 kilometers per hour and temperatures as high as 1,000 degrees Celsius. In addition, the poisonous gases that are released also present their own issues and can cause acid rain and destroy the ozone, block sunlight, and more. In contrast to explosive eruptions, there are effusive eruptions that are gentler and a result of mafic magma. Even though the pressure was enough to allow the magma to reach the surface, it does not erupt in the same manner as an explosive eruption. Typically, effusive eruptions allow enough time for evacuation of the area and are not as deadly. In today's discussion, we cover the parts of a volcano, magma composition, and how it affects the type of eruptions. Make sure to join us next time. Until then, have a wonderful day. Thank you.
1, 2, 3. Cheese.